So I want to focus on into the certain aspects of one prize object in the exhibition, which is of considerable interest to me because I've spent a lot of time working on the author who is behind it, who is Claudius Ptolemaeus, or Ptolemy, the most important sort of physical, mathematical, scientific writer of the height of the Roman Empire, sort of 2nd century of our era. You could say in a sense he's a kind of counterpart to Galen in the medical sciences at that time, though their personalities are very polarly opposite. We don't have any portraits that are authentic of Ptolemy, but there are many imaginary ones that were done in the later Middle Ages and the Renaissance. This is a little vignette from the initial of the word Cosmographia, the title that was used in Latin for Ptolemy's geographical work, which is about how to make a map of the world, and it shows this rather heavily dressed figure, considering he lived in Egypt, drawing a map which I'm not quite sure what. That's probably part of the river and lake system of Africa that's been put there. It's quite detailed. It's not a very big picture in the manuscript. It's a Vatican copy of Ptolemy in Latin. Now Ptolemy's work sort of centers on astronomy, really, not on geography. The geography came to be, particularly in early modern Europe, the sort of central work that was most influential, certainly for more than a century. But it was a kind of a byproduct of his interest in the heavens and trying to work out detailed and accurate theories of what the heavenly bodies do and relating them to what we see them doing in the sky from our viewpoint on the Earth. And so, I mean, one of the things that you may need ultimately to be able to do when you have a system like that is to know what difference it makes where you are on the Earth for looking at celestial phenomena, which means that you really need to have geographical data of some kind. And it's really out of that motivation that he turned to look at what was the available body of information that you could use to produce a sort of catalog of places for astronomical purposes. And he came to believe that it was actually necessary to address the whole question of representing that data pictorially in a way that was better than it had been done before. So I want to pick on 3 themes very briefly that come out of this. One of them is the idea of representing the 3-dimensionality of our place on the Earth and in the universe, which is something that for Ptolemy was very important. A second is the problem of persistence and survival of the picture. One of the reasons that the Ptolemy World Map is a very special highlight in the exhibition is because, in a sense, it is our one surviving ancient world map. Not because we have ancient copies, but because the copies we do have are a pretty reliable representation of what it looked like in antiquity. And the question is, why was it possible that that particular picture of the world survived when so many that we know existed didn't? And the third one, very briefly, about the question of improving the picture. To what extent were people in the scientific traditions in antiquity conscious of that there were going to be future improvements in data, in technique of representing data, and so on, as opposed to the tendency one often does see in ancient writers of saying, well, we're better than our predecessors, but we've about reached the limit, which is a very common point of view. So I want to begin with the 3-dimensionality. Of course, the issue here is the awareness that the world is spherical. This is, unfortunately, the modern school system seems to have trained people to think that Columbus was the first to do this. And I'd just like to emphasize, first of all, that there was a very broad awareness that the world is spherical, but that it wasn't a trivial matter to make that coordinate with making maps. So I'll just show you one of the pieces of evidence that was routinely used when setting out this basic idea that the world is round. There were many arguments that were used for this, but this is one of the most vivid ones. If you watch an eclipse of the moon, then what you see is a dark area gradually growing over the moon. If it's a total eclipse, then there will come a point at which the moon becomes totally darkened, not invisible, but a kind of rust-colored red. This is a sort of time-lapse set of photos of a typical lunar eclipse, and the top row shows the first stages leading up to totality, and then the middle is the totality. Those are artificially a bit brighter, just because that's the way the photographs tend to work. And then the last, you have to read backwards for this. No, you read basically from left to right in each row, are the ending part while the moon is sort of returning to full visibility. And the key thing here is, what does the outline look like as the eclipse is beginning and as it ends? And it's pretty clearly an arc. It doesn't look like phases of the moon. Particularly when you look at the beginning and the very end, you see an arc-like notch in the disk of the moon, which is different from the sickle-like darkening that you will get when you're near full moon but not quite there. So this is obviously something different from phases. And at a quite early stage in Greek natural philosophy, the theory that it's caused by the shadow of the Earth being cast on the moon becomes well established. And so that shadow clearly has arc-like outlines, and it really doesn't matter what eclipse you're looking at, whether the shadow seems to be coming more from the north side or the south side of the disk. The outline of the Earth always seems to be part of a bigger circle than the moon's own disk. So this was a very powerful indicator that the Earth is not just bent in its surface, which is comparatively easy to realize when you travel a lot and see, for example, how high does the sun get at noon at various times of year, but it really was round like a ball. Well, is this just sort of knowledge that the more technical scientific community had? Well, no. And again, just as Roberta showed coins, also some coins too, because these are things that, of course, not everyone got gold coins, but these look nicest in slides. And there are lots of bronze and silver coins that show these same sorts of images. They're showing, in the upper one, you're seeing in a coin from the reign of Augustus's astrological pet Capricorn, which had some strong association with his horoscope. It's not absolutely certain what. More or less holding under its forelimb a globe. And if you look at that globe carefully in a well-preserved coin, you see that there are lines, like circles, that are standing out on its surface. And the lower one, this is from the reign of Domitian, shows an infant, so more or less sitting on top of a globe. And again, you can see these lines that are drawn on them. They're conventional representations of the circles that astronomers imagined as being on both the celestial sphere, the heavens around us, and on the terrestrial sphere to represent, well, what we would call the equator, which is well, in the heavens, it's the apparent path of the sun on an equinox, and tropic circles, which are the limit of how far north or south the sun can get, and so on. So these, they're not accurately done pretty well ever on these things. What you typically get, you get the sort of hot cross bun kind of pattern, which is not good science. But it's the image of the globe itself, which is very, very widespread. Coins, but also mosaics, sculpted on facades of buildings. So this is an image that was very, very familiar to people. And presumably they may sometimes have puzzled about what kind of a message is being given on these coins, but the globe part is pretty clear. And it's usually a representation of the power of the Roman Empire and of the emperor, which is presented as being practically global. Of course, it wasn't. It was only a fairly large patch of Europe, North Africa, and a bit of Asia. But there was always a sort of propagandistic sense that all the important part of the globe, at least, was under Roman rule. So this image as a sort of fuzzy picture of the terrestrial globe is very common. But then when you look at, and I apologize for the little blue blotches, which were my failed attempt to get rid of the background. This is a reconstruction of the world map that was produced by Eratosthenes in the mid-3rd century BC. We don't have any actual copies of this thing that come down to us as pictures. but what we do have are geographical texts that describe its outlines in words. They're not precise enough to know exactly how the various features looked and exactly where they were, but if you don't insist on the details, this is probably a pretty good representation of what it looked like. You see that it's essentially in a rectangular frame. You have drawn over the map, you have horizontal lines and vertical lines, which are representing principal parallels of latitude and principal meridians of longitude, but they're drawn as straight lines. They don't look like circles. This doesn't look like part of a globe. And that seems to have been the typical way that world maps would have been done from, well, at any rate, from about the 3rd century BC with Eratosthenes up to early 2nd century of our era. And so what they're able to represent a lot of information about localities and their spatial relationships to each other. But they're not very good at two things. One is indicating relative sizes of, how big are the areas of islands or countries and so on, because the rectangular framework causes the parts that are near the equator to be squished, and the parts that are further north, these maps typically didn't, either would go not quite down to the equator or just a little beyond. So the parts that are at the northern limits of what was known in Europe would be very exaggerated in size, like on modern Mercator maps, where you see, Greenland looks as if it's bigger than Australia, which it isn't because of the distortion of the framework. So you have this sort of misrepresentation quantitatively, and you also have the failure to give the impression of looking at part of this spherical body, which everybody is supposed to know is the shape of our world. Well, why should that matter? Well, for someone like Ptolemy, it matters because he considers it to be even ethically important for people to have an accurate sense of what is their place within the broader cosmos, which is thought of in this sort of Platonistic tradition that Ptolemy more or less adhered to as in itself a partly divine living being, where the soul of the universe is up there in the heavens, and where we have this rather minor place. Yes, we're near the center, but we're on this minuscule globe, and not at the center of that minuscule globe, but on the outside, sort of like fungus growing on a piece of fruit. So we're not terribly important in the big scheme of things, and it's important for us to have that sense that that's where we are, and that's our proportion to the whole. So here is a manuscript copy of Ptolemy's map, and it shows you what he did accomplish in the sense of giving the visual impact of looking at a part of the sphere. It's not a true perspective picture. That would have been essentially impossible to combine with the other functions of the world map, which are to give you a good representation, not just of where places are, even at the limits of what's known, but also how big they are relative to each other. If you try to take a snapshot of a globe as like a perspective picture, you're not going to show the edges very well because they're bending around the sides. Ptolemy thinks of the known world, which for him goes from the Atlantic to what we would recognize as central China and Southeast Asia. So it's really pretty big expanse that's known in this period. He thinks that it goes halfway around the globe, which it doesn't. It goes more like about a third. So a perspective picture that is true sort of central projection perspective, like in Renaissance paintings, would not do. He knows how to do that, but he isn't doing that. What he's doing is a kind of quasi perspective that shows all those circles on the globe as being circles on the map, and that's squishing things in the north and stretching them toward the equator so that you get a pretty good preservation of relative areas too. So those two sort of didactic goals that he has are being preserved quite well. Now, he's the only ancient cartographer we know of who has these concerns, which is interesting, but it's partly that we don't have very much of the technical literature on cartography. It's mostly most of what we know outside of Ptolemy is coming from sort of second-hand writers like Strabo, who aren't, they feel a duty to talk a bit about the mathematical end, but they don't really feel comfortable with it generally, so they tend to be a bit skimpy on the detail. But after Ptolemy, sort of mid-2nd century of our era, the record pretty well disappears until we get into the Islamic Middle Ages. And this line of thinking about representing through mathematical structures of the grid of lines of latitude and longitude really only gets picked up again and developed only in the early period of printing in Europe. And you get things like the Werner projection, which is like taking to extreme what Ptolemy's doing now with a known world that goes far more, well south of the equator. So this it forces one, if you want to keep doing what Ptolemy is doing, into a kind of heart-shaped map, which in a sense has lost a bit of that impact of looking at part of a globe because it has that pointed bottom. But on the other hand, it's really it's going beyond Ptolemy and preserving the areas very well. So this is taking the mathematical ideal of Ptolemy to about its limit, sacrificing a bit of the representational virtue of the Ptolemy map as a price of it. And then you get other people like Mercator with his famous map, who give up essentially on both. Mercator's map is like going back to a Hellenistic rectangle frame map. This is all different from the amount of information that's conveyed in the map about the individual places. Of course, Mercator's map, which is enormous, it's on many sheets. This is stitched together to make a single image. Has far more places than any surviving Ptolemy map does. But Ptolemy's map actually was meant to contain 8,000 localities. It was intended to be made probably as a large-scale wall-size thing, because you can't really fit that much detail onto any small medium like a manuscript in Antiquity, or even the printed Ptolemies of early modern times really only have the most famous places marked, and you have to page on into the atlas part to see the details. So that's one of these issues about the, thinking of the map as representing this three-dimensional object. How do you do that on a flat surface? Another point I want to develop, and I'll be briefer because I'm running over time, is how one preserves this image and how one allows for development. And Ptolemy has an approach to this as well, which seems to be original with him, like the sphere representing grids. It's to digitize. It's a very modern concept, it sounds like, but Ptolemy recognizes that pictures are hard to copy without they're getting spatially distorted. So if one can take a picture and take all the key points along it, or at least a dense enough grid of points on it, and turn them into lists of text to write and where on the grid this point belongs, which means its longitude and latitude, then you can provide a kind of coding of the map, which someone can then transform back into a picture that will maybe differ in the colors used and any decorative features, but in terms of the graphic object, it ought to be identical, except for the effect of miscopying the lists of numbers, which does, of course, happen. But that produces a different kind of error from copying pictures. I don't know if Ptolemy really thought through what it did, but it adds noise to the picture, mostly on a rather small scale. The map loses its accuracy in the fine representation of places, but the big picture is pretty well preserved. So you get, here we have a map from the late 1400s, which again is done from Ptolemy's coordinate lists ultimately, and it's we can be pretty confident that if you don't insist on very precise positions being right, it's representing what Ptolemy must have drawn in his own workshop well over 1,000 years earlier. The other thing, just to close, is that Ptolemy does recognize that the actual database for drawing the map is very poor in his time. It's very extensive. It goes, thousands of miles in all directions from Alexandria, but the quality he recognizes is very poor and really needs a more scientific approach to producing an accurate map. So when he describes how to lay out the manuscript with those tables, he says leave big margins so that later people can write in better numbers and additional places. Then this doesn't really seem to have happened. The medieval tradition of Ptolemy as manuscripts largely is without maps. Some manuscripts probably did have maps from late antiquity anyway, which would have had to be rather small compared to what Ptolemy had in mind. But any alterations that are happening that aren't just accidents are probably just little local adjustments that people make. And even here, and this is late 1400s, we have a printed Ptolemy, and it's essentially a map of the Roman Empire and Asia as it was in Roman times, and some of Africa south of Roman Africa as it was known in the 2nd century. And yet this was meant, this is presented almost as if it's current geography 1200 years later. But you'll notice that there's a blob up in the upper right, which is getting outside the framework. And this is where this is already showing in manuscripts done a little bit before the printed Ptolemies. People are adding Scandinavian details that aren't in Ptolemy. The one area that quite early on, relatively speaking, starts getting updated. But the rest of the map is frozen. It stays pretty well that way for quite a while.